Good evening, ladies and gentlemen, and welcome to the Tiscon Discovery webinar series, the 14th in the series. And I'm Kshemendra Nath. I'm the founder director of Resilient Energy India Private Limited. I'm very happy and privileged to be here to address you all on the subject of construction and demolition waste management in India, the challenges, the opportunities, and the enablers. I will, during this course of this webinar, I'll speak to you for 50 minutes. There'll be a 10-minute for question and answers, which you can type in, and I will answer those questions. And if I'm not able to complete all the answers, I'll get back to you through mails. So, what in the course of the next 50 minutes, I'll be talking to you about the challenges posed by the construction demolition waste generation in India or anywhere in the world, opportunities for utilizing the C&D waste. I will also run through with you the case study of ILNFS in Delhi, who have been the forerunner in construction demolition waste management. I'll talk to you about the enablers for success for a successful operation of for the successful operation of C&D waste management. And Sintef of Norway has been doing a bilateral project in India. I'll give a very brief about what they do with supporting the Indian initiative of construction and demolition waste. So, okay. What is construction demolition waste? Any waste that is generated during the construction, demolition, or refurbishing is generally termed as a construction demolition waste. 50% of the waste generated is in the form of concrete and masonry, and then you have a heavy load of soil and gravel which comes along with it. You get wood pieces, you get asbestos, you get everything mixed together. So this is what in general is generated during the construction, demolition, or refurbishment time. Let's look at what is the construction demolition waste that is generated in India and what are the estimates. If you can look at this table, the Ministry of Urban Development in 2000 came up with an estimate of 10 to 12 million tons per annum. Technology Information Forecasting and Assessment Council in 2001 came up with an C&D waste this thing of 12 to 15 million tons. Ministry of Environment in 2010 estimated this to be around 10 to 12 million ton. And in 2013, the Center for Science and Environment along with McKinsey came up with an estimate of 530 million tons per annum. Now, if you can look at this estimate, it's so divergent. It's too much to really understand where we actually lay between 10 million ton to 530 million ton. It also shows that there is a lack of actual understanding about how much of construction demolition waste is being actually generated in the country, and without understanding how much is generated, any kind of fixing the problem will be very difficult to start with. Let's look at what is the situation in the rest of the world, most of the developing countries and China, for instance. China generates around 2,190 tons of C&D waste in a year, and with a per capita consumption of 1.6. European Union, all put together, have a figure of around 510 million tons. USA around 317, Japan around 100 million tons per annum, and England around 100 million tons an annum. India, at the figure of 530, also gives something like a per capita tons of 0.4 metric tons compared to the rest of the countries where it is somewhere around between 1 and 1.6. So probably I would rather stick to a figure of 530 to be closer to reality than 10 to million metric tons, which has been estimated by many other agencies. Again, this is not accurate to the last metric ton generated, but it's very important that we understand where the ballpark is. Here's a clipping which came from Asian Age in 2013, which says that the demolition waste is 52 times more than the Ministry of Environment and Forest estimate. Here in this particular article, they talk about 630 being the figure in 2013. Now, whether it is 530 or 630, it says that, like we are vastly underestimating the actual CND generation in the country. Now, most of the CND waste that is generated goes into the landfill. And if we continue business as usual, then India will need a landfill the size of West Bengal to dump the 21,630 million tons of CND waste that is going to be generated in the next 25 years. Now, that's an awful lot of land to start with, and it's not going to work. What are the problems associated with it? Where does the CND go and ultimately find its resting place? It goes into the low-lying areas. It goes into unauthorized encroachment, water bodies. It is estimated that close to 1,500 water bodies have been lost in the Delhi National Capital Region of Delhi just by dumping of CND waste. 103 water bodies in Mumbai is under threat. And it's not just the environmental problem which is at stake. It's also the health and the safety issue. You have CND dumped by the roadside, creates accidents. CND dust accounts for more dust than the construction dust. Asbestos, which comes as a part of the demolition, is again laid out in the open. And we all know that asbestos is a carcinogenic material. And it can actually pose serious health hazards. So the burning of waste, road dust, and CND waste together account for almost 20% of Delhi's air pollution. And then this says a lot about the problem that is actually created by unscientific dumping of CND waste. If you look into Bombay, for instance, those who are familiar with Bombay know that the salt pans on the Eastern Express Highway is very ecological sensitive and it's a no development zone. Now, this is a clipping which has come from Times of India a year back, which talks about CND waste being dumped, and the residents across feel that there could be encroachment of the land. And this is the real worry. It is not just indiscriminate dumping, but it's also the unauthorized construction which comes on top of it. Worse is the situation in New Bombay. In the 1970s, using the Dutch method, CIDCO made around 11 holding ponds, which acts as a buffer for absorbing the high tide and even the surface runoff when there is a heavy rain. So this is actually serving the city to absorb any increase in water which comes in and prevent the city from flooding. But today, if you really look at it, this is an actual picture of the holding pond in Kalumbuli on the left side, which says that it has been encroached. On the right-hand side of the screen, you can see Nerul, where the holding pond has been converted into a cricket ground. Now, when you do these kind of things to a carefully designed method of arresting your flooding, then it's very natural that flooding comes and then it brings the whole city to a standstill. You look at Bangalore, it was once known as the city of lakes. In 1937, there were 937 lakes in Bangalore. Today, you have hardly 80. And out of those 80, there are only 34 which are live lakes. On the left side of your screen, what you see is the famous Belandur Lake, which actually catches fire. And it's so polluted that it creates such a lot of health hazards for the residents who's living close to that. On the right hand side, you see two other major lakes in Bangalore, the Varathur Lake in East Bangalore and the Kundanahalli Lake, where a lot of CND is dumped and is threatening to encroach this area. And slowly you find that the lake starts disappearing, and this is the way the CND waste is actually put to use by unscrupulous developers and unscrupulous people who want to actually grab the land. If you look at Sarfraz Khan, Joint Commissioner of the BBMP, says that there's a clear pattern. You dump the debris, flatten the land, construct it, and file a court in the case, and then you get along with the property. So there's quite a lot of things which is happening, for which CND waste is used or abused for all the wrong reasons. Now, I've given you 3 examples of 3 cities, but doesn't really mean that the rest of the cities are okay, are not having this problem. Each and every city is going through these kind of issues. The C&D waste is used for illegal flattening of the land and construction. Here is a figure giving you the waste generation in major cities. Chennai, the C&D waste generation is 2,500 metric tons. Delhi is 5,000. Bangalore is 875. Now, these are the figures which I have taken from the guidelines on the environmental management of C&D waste by the CPCB in 2017. At the bottom, you have Goa, which 525. Now, this is a particular exercise we from Resilient Energy, along with Sintef, has done in baseline data generation in Goa. Here, we have applied more scientific methods of actually determining the construction waste that is being generated from construction, from demolition, from refurbishment, and we have come with a figure of 525 tons per day. Now, this is an averaged out figure. Now, with 1.8 million population in Goa, you have 525 metric ton. Then obviously, Bangalore is not 875. You are much way below, again, the estimates. So we do not have a scientific way of looking and calculating what is the actual C&D generation, because most of them is unaccounted. Now, what are we doing in India for C&D waste management? The Ministry of Environment and Forest formulated a C&D waste management rule in 2016 and gave a clear deadline for all the urban local bodies to a time frame for implementing implementing of the processing facilities. But the deadline for cities with 1 million plus has already gone off by end of 2017. In fact, in October 2017, the deadline was finished. And how many cities do really have? You can count on your fingers. Delhi, Ahmedabad, Indore, Thane. I might have missed a couple of them, but that is not so many who are there as which have got operational C&D facilities. There are quite a lot of cities which are in various stages of implementation, including Pune, Mumbai, Hyderabad, Jabalpur, Agra, and the list goes on. But if you really see, India has got 40 cities with a population of over 1 million and 397 cities with a population of 1 lakh to 1 million. So what it means is that we are so far away from achieving what has been directed by the Ministry of Environment Forest through a regulation. Together with this, there are other things which the C&D management rules say. So for any project that generates more than 20 metric ton per day or 300 metric ton in total, they should segregate the waste into 4 streams. That means they want to segregate all the waste at the site itself into concrete, soil, steel, wood and plastics, bricks and mortar. It also says that they should submit a waste management plan and get the approval before the construction starts or demolition starts or renovation starts. Following the global principle of polluter pays, they have to also pay for the processing and disposal of C&D waste generated by them. Now, these rules have hardly been implemented across the country. We all know that. But at least there is a start. Together with that, they also talk about the distinguish between demolition, which is currently the practice, which is just breaking down of buildings and structure either manually or using mechanical force or by implosion, in which case you get a mixed waste because everything is mixed together. Or they actually recommend that deconstruction should be the method where it's more systematic. It's a plant selective process where you destrip the building, then you sort the material, keep it in different sorting, and then you demolish the material and take the rest of that you demolish. So this process will definitely help to reuse and recycle this in a much better way. So there has been a guideline which has been formed. There has been a lot of activities which the government and the government agencies have come up with to address this problem of construction waste. Now, coming back to this, on one side you have a lot of problem associated with C&D waste, and we have to address the problem. We just cannot allow business to go on as usual. But at the same time, the world at large is looking and staring at an aggregate crisis. Many of you may not know this, but sand and aggregates are the second most extracted resource in this world next to only water. Annually, 40 billion metric tons, which is approximately 9 times the crude oil, that much amount of quantity of aggregates is being extracted every year in this world. And aggregate demand has grown 360% in the last 30 years. So we are looking at one side where the demand for aggregates, which is not a material which never goes out of this one. You have a problem with aggregates. There is a limited resource. If you look at another startling statistics, China in the last 2 years have used more cement than US have used in the last century. So what it means is that development, especially in countries like in the Asian countries, is happening at such a fast pace that any development will definitely involve use of aggregates. India is also not very far away from this. India, and most of you who are in the construction field know that getting aggregates in time is a very big problem. And more and more aggregate quarries are going further and further away from your actual construction where it's happening. It is estimated that real estate development in the next 25 years will require around 55 billion cubic meters of aggregates. 750 million cubic meters of aggregates will be required for the road. So we are looking at a situation where you're having a huge demand and a huge pressure on the aggregate situation. And you know that aggregate and sand are not an unlimited resource, and we are fast depleting it. So on one side, you have a problem of managing the C&D waste. On the other hand, you have quite a lot of problem with availability of aggregate, which can prevent further construction. We need to put a proper action plan in place for the next generations to survive. And this is actually a very serious issue. Let's look at what the Indian standard says for use of recycled aggregates. IS 383, which was recently revised in 2016, has included use of recycled concrete aggregates and recycled aggregates. Now, the difference between the two is that when you recycle just pure concrete, it's called the recycled concrete aggregates. When you recycle aggregates which is mixed along with concrete and bricks and mortar, then it becomes recycled aggregates. So this is the difference. What the code says is that in plain concrete, up to 25%, you can use recycled concrete aggregates as a coarse aggregate. In reinforced concrete, you can use up to 20%, but only up to M25 grade as coarse aggregate. Recycled aggregate, which is a mixed aggregate along with bricks, cannot be used in reinforced concrete nor in plain concrete, but it can be used in lean concrete up to 100%. And recycled concrete aggregate can be used up to 25% in plain concrete and 20% up to M25 as a fine aggregate. Now, what this code also doesn't tell you is that can it be used 25 and 25 up to 50 as coarse and fine together, or is it only 25 as both coarse and fine together? It's not very clearly explained, but I feel the understanding is that you should not go beyond 25% of replacement, both coarse and fine put together. Now, when we look at this, we say that in concrete, you can only use so much of material. Then how can we actually put all this concrete demolished aggregates and recycled aggregates to use? But what we forget is that concrete is not just about 30, 40, 50 and high performance concrete. Clearly, recycled aggregates is not for high performance concrete. But then in this world, more than 50% of the concrete which is made is M25 and below. Most of the concrete which is made is concrete used or cement is used is in non-structural applications. So what it means is that there is quite a lot of applications where construction demolition waste or recycled aggregates can be used. And more importantly, in those kind of applications where it can be used, it can replace virgin aggregates. So you don't really have to use virgin aggregates into road subbase, and that can be used with construction demolition waste aggregates. It can preserve or conserve your natural aggregates for more time. And that is what we need to think about. So, having said that, how is the international best practices working out? Now, in the US, 23% of the C&D waste is recycled. Now, you know that 50 states in the US, every state has got its own law. The most stringent is in New York, where they do not allow demolition. They strictly all the buildings have got to be deconstructed or dismantled, and with a proper scientific approach. It also mandates that segregation of waste should be done at site, and so that your recycling capabilities are, the effectiveness of recycling can be much better. In UK, 28%, almost 28% of the total aggregates is recycled from of the C&D waste. Also, the landfill taxes in UK is around £100 per ton. So, if you want to dump something in the land, then the landfill, the taxes are so exorbitant that it will make you think and encourage you to go for recycling. European Union has got a target of 70% material recovery by 2020. It's a very stiff target. I think they are somewhere around 30-35%. But then this is mandated by the European Commission Waste Framework Directive. Coming down to the Asian part of the globe, Hong Kong has got an interesting model. Now, there is a C&D waste tax on developers. 100% waste utilization, the project which can achieve 100% waste utilization is charged $27 per metric ton. And when your recycling is below 50%, then you have to pay around 125 metric tons, $125 per metric ton. And this is a very clear incentive and a very clear penalty for people. So it's encouraging more and more developers to do recycling. In South Korea, they were one of the first people to start on the recycling of C&D. They had made C&D waste management as a part of the low carbon growth strategy. And today they have reached an effective recycling rate of 36% with a target of 45%. Singapore and Japan has achieved 95% of waste concrete recycling. Now, when we say these figures, it doesn't necessarily mean that all the material that is recycled is going back into concrete. That's not the case. But it has been effectively put into use in different applications so that it doesn't go into the landfill. Australia, for instance, has got at the moment around 45% is 45 to 50% is the effective recycling percentage, and some states in Australia has even reached 70%. So if you see worldwide, there has been very good uh, movement and a lot of encouragement to go in for recycling. So when we come to this, what are we trying to do right now? We are following at the moment what is called as a linear economy. You extract the material, use it in construction, you then demolish it, and then you fill into the landfill. It's a linear economy. You take it out and then you fill it somewhere else. But the real way forward would be to have a circular economy approach, where the materials and the energy is put into a circular form, it's into a cycle, a never-ending cycle. So if you have demolition, you use it, transport the waste into a recycling facility, you clean it out, reprocess it, and then you get back to another application, so that the material is always in circulation. And with this, 95% of the recycling is targeted to be achieved by this recycling methods. So, having put you set the picture up, let's look at what is it that we are doing, and what are the success stories we have in India, and what are the enablers, and how can we move forward. The major components of C&D waste, this picture is a very good picture of telling you how a C&D waste dump looks like. So it's not just concrete. You can see concrete there, you can see bricks, you can see rubble, you can see gravel and mud and mortar, and lot of and also pieces of wood. So if you want to process this, then you need a proper facility. And it's also important, looking at this picture, you can really visualize that if this had been sorted, if concrete has been segregated, if bricks have been segregated, if wood have been segregated, it would have been much more easier to recycle it. But this is the current situation, and we have to deal with it. So what is a success story we have in India? ILFS in Delhi has been the forerunner of doing a good bringing into India the recycling facility and the recycling plants. They started in 2009 February, exactly a year ago, at Burari, and this was when the Commonwealth Games, the construction for the Commonwealth Games is started. Then this started with a 500 tons per day plant, and now they are at a 2000 ton per day capacity. In 2015, they added another facility in Shastri Park, which is a 500 tons per day plant, again in East Delhi, along with the Delhi Municipal Corporation of East Delhi. And the latest to add was 2 years ago, in July 2017, at Munka, where they have tied up with DMRC for this. And they have some plans to come up with more facilities. Let's have a look at what they do in Delhi. Before we go, we need to understand between the wet process and the dry process. When you deal with construction demolition waste, which is coming from different sources and mixed together, then you really need a wet process facility to clean the aggregates, segregate them, and make it useful in your application. This is a picture of a plant which is in Velde in Norway, near Stavanger. And this is one of the wet process facilities. Here you don't have the crushing, but it's more of cleaning and recycling and getting this aggregate back to useful applications. The plants in Delhi also has got wet facility, and I think most of the plants that has been coming up, C&D is all wet processing. Let's look at what the step-by-step the processing method. First is to ensure that the proper material is properly inspected, because when it comes from different sources, there is quite good possibility that this could be mixed with municipal solid waste. So inspecting the incoming material on the weighbridge, removing of the material, removing the metals, plastic, rugs, and wood, and this is done manually by people just picking up the plastics and the metal, and then this waste is segregated into two. One is the concrete stream, which is purely neat concrete, and the other is a mixed C&D waste. And when you process, you have two parallel streams, which has got two different processing facility. The big pieces are resized to 200 millimeters to up to 400 millimeter size. After this, on the concrete stream or the dry stream, it is put into a grizzly. As you can see on the top side, on the top right-hand corner, the picture shows the aggregates being cleaned by sprinklers. So the concrete, although there will be mud and clay or things like that, which is sticking onto it, it's cleaned up, and after cleaning, it's crushed, sized, and then it is separated using three-step pro-grade streams. So you make aggregates according to the requirement. So 20 to 10, 10 to 3, and 3 and below. And this, after segregation, cleaning, crushing, segregation, it goes on to the stockpiles for delivery outside or testing. The bigger challenge is on the mixed stream, where you have concrete, bricks, and other things which comes along with it. For example, if you have a house with a concrete slab, a column, and a brick wall, and when it is demolished, you will get pieces of bricks also sticking along with the concrete. So this cannot go in as a recycled concrete aggregates. This will be a mixed aggregate and is treated separately. The mixed stream normally goes through a wet processing cycle. So it goes into the log washer. In the log washer, the lighter material like your wood and plastic is floated off, and it is collected into your on the rear side of the log washer. So you get the cleaning. Again, through attrition, the mud is cleaned off from the aggregates or the bigger screens. Then it goes into a crushing situation where it is crushed to different sizes, and it is screened again through a 3-deck pro-grade screener. It is converted into 20 to 10, 10 to 3, and 3 and below, or whatever sizes the market demands. So basically, it's a process of cleaning, crushing, and screening. And after that, the 3 mm down, which is basically the sand, is sent for further recovery into the aqua wash. And in this aqua wash, using the hydrochlone washing system, it segregates 3 mm down, 75 microns and above into sand, and 75 micron and below into the silt. The sand goes back after cleaning and processing into the stockpile, whereas the silt is taken away and then may convert it into a sludge using flocculants. Then it is sent to a press into a filter press, what you see on the right hand bottom corner. And inside the filter press, under pressure, the water is taken off. The taken off water is again recycled back into the system, and then 90% dry sludge falls off. This sludge can also be used in clay, as in brick making or in block making. So this is in a nutshell what happens in a C&D facility from an operations standpoint. When you look at the typical composition of C&D waste in India, on the left hand side, 36% is soil, sand and gravel. 31% is brick and masonry. 23% is concrete. Then you have some metal, 5%, 2% is bitumen, wood and others. So this is a typical composition, especially in what the experience tells us from ILFS in Delhi. But this need not be the same everywhere, but maybe in the same ballpark. And what do they actually produce out of this? So after taking this material in, the output is around 22% is loose soil, 26% is mixed brick base, 12% they use for the granular sub-base for the roads, 27% of the material output is converted into manufactured sand for concrete, 11% of their product goes into making precast blocks or bricks or pavers. So only 2% of their material goes back to the landfill. So if you can think about my earlier slides where we're talking about the whole C&D will require the land the size of West Bengal to dump. Now that 100% instead of dumping, now we are only looking at 2%. And this is what a good C&D facility can actually do. 2% is a very efficient recovery, but generally they target up to 5% going back to the landfill, 95% recovery. That's what they are normally targeting. But it's good that we are able to achieve 2%, 98% recovery in Delhi. So there is another process also which can be done, and I should be talking about mobile crusher units also as an option. But this is ideally suited for processing clean demolished concrete with no mixed waste. So for example, if you have a large project and you have a building to be demolished and that building is more or less clean concrete without any mixed waste, then you could also use a mobile crusher. And these mobile crushers are usually very handy. They also come with good dust suppressors and dust suppressors and also proper sound proofing. And this can be used this can also deliver something like 50 metric tons per hour, up to those kind of capacity. So it is a very handy material, but it's only limited to use in certain circumstances where we are assured of just clean concrete. Let's look at what are the applications which can be used in what are the application of these products. Like I said earlier, you have something around 27-30% of concrete aggregate products that can be used in concrete. But a large amount of material are like loose sand. You have material like the mixed brick bats. So where do we use? Brick chippings is a very good drainage substrate for a green covering. So if you are developing a lawn or a park and you want the water to be drained back to the groundwater, then you can use brick chippings as a drainage substrate. You can use very well into the subbase or the granular subbase for the roads. Loose soil can be used as gardening and landscaping. You can use brick sand for sports facilities and tennis courts and all that. You can use concrete. You can use this for pavers and precast. Sorry. And one of the more unconventional applications which have been developed is the garden furniture. For instance, Godrej Building Materials in their operations in Vikhroli, they have developed this concrete bench which can be used in the parks. And you can make stools, you can make quite a lot of innovative things to really expand the use of recycled aggregate. So one need to think beyond the box to actually use and maximize the utilization, because all that is reprocessed, the output is not going to go into concrete. There will be quite a lot of other materials which we need to find very good applications for. Here are some live examples of what's happening in Delhi. They make quite a lot of concrete blocks, they make pavers, they make bricks in Burari. They also make a lot of granular subbase for the roads. And the new Supreme Court building, for the new Supreme Court building, more than 28 lakhs of concrete blocks have been sold. And the CPWD has mandated the use of concrete blocks with using recycled aggregates. And this has actually been a big fillip to the industry to actually see live how this is being used. Delhi Development Authority, for instance, have used more than 5 lakh of tons for the subgrade replacing. And here again is a wonderful example how virgin aggregates can be saved by using construction demolition waste. So again, I would like to reiterate the point that construction demolition waste is not all about using in concrete. There are different methods by using, but then there are two golden principles. One is to use this in a gainfully in a proper manner, so that there are no these are not dumped and don't create an environmental problem. And second thing is to actually save your virgin aggregates, because these aggregates are not going to last forever. So we need to think and make sure that we hand over this world to the next generation, also to enjoy what we had enjoyed. Now, what are the factors which goes into, what are the enablers to make a good construction demolition recycling operation? Now, we have talked about the problem, we talked about the solution. Now, for this solution to be effective, what do we have to do? There are quite a lot of enabling factors. Government policies, for instance, financing. Now, we know that construction demolition waste, investing in this is not a big investment proposal like you do a business. So there has to be, with the current borrowing rates, it will never be a successful venture. So we need to look at financing. We need to look at collection efficiency, because if you don't collect the material and then people don't actually dump don't segregate the waste and put it in the designated areas, then the plant will be idle. So collection efficiency is extremely important. Quality systems, there should be a documentation, there should be a certification which gives the confidence to the end user that I can use this because this is a certified material. Because concrete waste comes from many different places. It could be subjected to sulfate contamination, it could be subjected to chloride contamination, it could be actually coming from different sources. So how do we actually ensure that when it comes over, that the output material is good enough for using in concrete? So we need proper documented quality systems. And we also need, as we said before, we need to develop wide applications which can actually use the utility of this product can be used more. So let's start with the government policies. C&D management, waste management today is a part of the solid waste management of the urban local bodies. Now we need to have a dedicated team, and we need to have a chief engineer for the C&D waste management and dealing this from the solid waste management. Then only we get the right focus, because solid waste and C&D are two different things. It needs to be approached that way. Even today, when we estimate, for example, in Mumbai, when we look at the C&D, the solid waste management, and we look at the statistics, the estimate is that the MMR area has got around 12,000 tons of waste that is generated every day, and then 30% of that is C&D. Now, that is a wide approximation. We don't really know it is 30% or 25% or 40%. So we need, until and unless the focus is there on C&D with a chief engineer level person, we will never be able to make great progress. We should have enough land to maximize the transport cost. Consider multiple locations if necessary, because a city like Mumbai or Delhi will need multiple locations. You can't do everything in one place and expect the material to be transported all the way from, say, for example, from Colaba to Mulund. So we need to look at practically, how can we minimize the transportation? There should be good tax incentives for the C&D based products, because again we are talking about investment and making the investment work, and good tax incentives are a very good way of encouraging people to use C&D materials. One of the biggest problem is the inventory or the offtake of the material. Now, if you have a C&D facility, you are crushing and you are making all the best material to be used, and there are no offtake, then the whole operation comes to a standstill because the inventory has blocked your entire operations. So to make this smooth, there should be a seamless way of incoming material, processing, and the material going out of the plant. To have that, the urban local bodies should have to provide a guaranteed offtake, because you have a lot of products which can be used in many of their activities. Even if they say 20% of their municipal government requirements can be taken, then that will normally take care of a 500 ton per day plant. So these are the things which we need to really think to make it happen. From a private development point of view, for big projects, there should be an incentive, or they should make it mandatory that the permissions for construction of big projects is only granted after you give a comprehensive C&D waste management. Remember, a lot of construction waste is being demolished. A lot of buildings under construction also get demolished for whatever reason, and all this are going in and going in different places, which is not being accounted for. Link the occupation certificate to use of C&D products. So in a way, if you are building a big project, you make to sure that you have a comprehensive plan in place and you document it and submit it for your occupation certificate to be given. And this will actually encourage, or like it will make this more effective. And as I said before, the financial this thing is very important, because for the Swachh Bharat, there will be grants from the Swachh Bharat can actually put less pressure on the person who is investing in a C&D facility. You don't get 20%, 25% return on this business. So you need to also make sure that your loan or the borrowing rate is also low. So in many places, they will not, the person who's going to put up will not have access to multilateral finances from IDB or IMF. So there should be ADB or IMF. So you should make some support so that you secure loans at a lower rates, which makes it all the more easier. And we don't really have idea how much is being generated. So the urban local body should actually keep track of the C&D activity. It should map the quantity, the waste characteristics. You should be able to understand what is the waste stream. And if you really put a plan in place, it's very easy, or it's not that difficult to actually measure and monitor. And ensure that stiff penalty for illegal dumping of C&D waste. You should encourage segregation at the site. We have seen that picture with C&D waste coming with all sorts of things, the cement, the concrete, your mortars, bricks, and gravel. So you should actually try to encourage segregation at the site and provide storage bins at regular distances, so that there is an encouragement for a person to go and then deposit this in a place with the right facilities. Periodic collection and transportation with GPS enabled dedicated fleet, so that when the truck goes out, you can track it, that it has gone, collected, and it has come to the real facility and not dumped elsewhere. We need to have a proper documentation of process, operate to a quality standard, and certification for the recycled material, so that a person who is using it has got the confidence that this is something which will not create problem for the structures. And this is why I said, because you have concrete and the material coming from different multiple sources, and it's always difficult to actually use the material without knowing the origin of the material. So it's important that there is a documentation process in place, a good quality system in place, and a certification program which actually encourages people to use this recycled aggregates. And finally, when you look at this, you know that up to M25 and up to maximum of 20% is what can be used in concrete. So we need to look beyond concrete and the materials like, the precast toilets and urinals, garden benches, garden pots. You have to really think out of the box to actually see where we can use in non-structural applications. And this is extremely important together with use in conventional products like your bricks and blocks. So having talked about it, what is Sintef doing in India? Uh, Sintef, if you may not know this, is the largest R&D organization in Norway and is the third largest research and development organization in Europe. Through a bilateral project from the government of Norway and the government of India, Sintef will provide assistance, the technology, and their experience to support the Indian companies and organizations to utilize the CND facilities, much CND waste management. So 2 years ago, Sintef got into an MOU with the CPWD, and the main objectives of this project was one, to first have the baseline data generation so that you know exactly what is the kind of CND which is being generated, waste that is being generated in different places. It looks at the international best practices so that we know that, like we bring in what is being used in other parts of the country or parts of the world to India so that we don't have to go through the learning curve. It talks about there's also a part of capacity building and training so that people are aware and people do the right things. We're also in Sintef. Another objective is to do pilot projects, demonstration projects, where use of CND material is successfully done in projects so that the customer confidence can be built, and also use this experience and this thing to change the guidelines, so amendment to the guidelines for proper utilization of CND waste. So this is the project objectives and what we have done till now. Just go through very quickly. In ILFS Delhi, we know that CND waste facility management facility has been working for the last 10 years. Now what we are doing is that we are doing a quality assessment and documentation. So when we do this, this is not a spot testing. This is a regimen which is worked out over a period of time, setting out what is the periodic assessment of the batches, looking at critical parameters for the aggregates like specific gravity, water absorption, acid-soluble sulfates, acid-soluble chlorides. Look at either the declared value and see how it varies within the declared value over a period of time, or with the different batches, or look at the limits at which the standards talk about. For example, specific gravity and water absorption, these are the declared limits. We say that we want this material to fall within this particular range so that the variability can be reduced. Water absorption, for instance, is again another area of importance where you design your mix, you need the water absorption to be within a particular band. Acid soluble sulfates and chlorides to ascertain how good is the, or how, whether that has got contaminant chlorides and sulfates which can create problems. So it is a periodic assessment of this, certifying what can be used and what should not, what cannot be used. Along with this, we are also supporting the government of Goa in sustainable management of CND waste. For the Goa Waste Management Corporation, we have done a baseline generation of data. We have done the waste stream classification. We are now coming up with the profile for the plant configuration. We're talking about the business models, and we are also putting in place the transportation collection facility, the transfer stations, and the whole plan. And once we implement this plan, this would be an ideal document or a model case for the other cities to follow. We are also working with Godrej Building Materials in Mumbai, and we are very close to start at least a couple of projects, pilot demonstration projects, where we use concrete from recycled, where we make ready-mix concrete and precast for the real life application. Another interesting project what we are doing is looking at the CO2 footprints in the concrete block. When you use CND waste, you have quite a lot of material which are unbound, which has got some motors, and this is good for attracting increasing the carbonation. When you don't use in when there's no reinforcement, carbonation is good, especially in blocks. So it can help you to arrest carbon dioxide. So there's quite a lot of good things which is happening. And I would say in conclusion that C&D waste management is critical. We have seen what it can do, how damaging it can be for the environment. It's very important that the government policies are in place, and more important that effective execution, which is very, very important. Not having just having rules in place will not help. You need to make it work. Uh, we know for sure that it has got the potential to replace the in some applications fast depleting natural aggregates. So we need to be smart, we need to be more thinking and inclusive about how we manage our resources. We need to look at segregation of the waste. We need to look at deconstruction as an economical and environmental friendly alternative to demolition. And we should do away with things which don't help us, and adopt a mix of regulation standards to set the framework to guide the private sector to adopt good practices, because we owe it to ourselves, we owe it to the next generation that we we manage our resources much better. Thank you all for your attention. I can take the questions now. I have quite a few questions which have come, and I will try to answer it from uh, this is one question from sir. You send the PDF. Of course, the PDF will be available through the webinar, and I'll make it available to you. How can we segregate the demolition material on site? Suggest any packaged plant technology for recycling. This is by Abhijit Galadge. Now, if you are segregating the demolition waste, you have to do it especially when you are demolishing, you have to follow the principle of deconstruction. Now, when you say deconstruction, it is you strip the building first of the wood, the plastic, the aluminum, the glass, and then you strip then you have a planned process by which you take out the bricks, segregate the steps, and then you demolish the concrete and keep it in a separate step. So when you do it in a more planned and executed manner, you can actually salvage much better. So this is the system, and I can go more further into it, but I have to look for the other questions. But this is what needs to be done. Otherwise, if you're going to demolish it all in one go, then you're going to get a mixed waste, and then you are not going to get effective recovery. What is the cost of recycled concrete coarse aggregate? Okay, now the cost of recycled coarse aggregate depends on a lot of other factors. One is to start with, what is the incoming material and what is the output, what you get out of it. The more concrete you get, the more lesser will be the cost, because you can sell concrete aggregates at a higher price. Having said that, the cost to recycle, assuming the kind of composition we have talked about, uh, comes somewhere around 200 rupees a metric ton. And then you need to also factor in your investment costs and the interest cost on that. So ultimately, uh, by the whole cost I would assume would come around 350 to 400 rupees per metric ton. So this is the reason why in an area like Bombay, where you have 900 rupees a ton, it can be made viable. But if your total cost of aggregate itself is 350, it becomes very difficult. Is it good for construction of residential and commercial building in small cities G1 and G2? This is Amarendra Kumar. Of course, we have to go by the guidelines, and then again we need to understand that in concrete up to M25 you can replace up to 25%. Now that is the limit at which you should use. It's not just using it, it's also understanding whether how much can be actually used, understanding the water absorption. You have to look at the variability within the material. So it can be used, but it should be quality assessed, it should be certified, and then you can use it on a regular basis. I have a question from Anjan Nandi. As India old buildings almost 60 to 70 years, especially residential project without C&D management. Need of the hour. We need pan-India rules and regulation for national saving. Yes, Anjan, I agree with you. And we have a C&D pan-India rule, which I've talked about. It is the Ministry of Environment and Forest and Climate Change, as the ministry is known today. They have come up with the C&D rules 2016. The major problem is in the execution. And until and unless there is a regular monitoring and the willpower to execute it, then a rule doesn't really actually matter. So there should be incentives, penalties for all the urban local bodies to make sure that this is implemented. What is meant by MOU? MOU is a memorandum of understanding, and this in this context it is signed between the government of India for CPWD for the government of India and SINTEF for the government of Norway. Srinivasa Rao asked this question whether it will be considered in the Griha rating for recycling of CAD. If Griha rating is, I haven't understood this Griha rating. If Griha rating you mean is the LEED certification and other incentives for using for the low carbon footprint, yes. But then we have to work at actually getting this specified into the others. Is specified into many of this rating, and also we need to make this rating very effective so that there is some incentives. And once we have that in place, we can actually make better utilization of the C&D waste material. Which type of materials can be used for new construction generally? Manish Mishra, the materials that we can use for new construction, uh, you can use C&D aggregates made out of C&D. Of course, you can use them. But as I said, it has to be properly certified, and then you have to make sure that you know the origin, or at least the material is tested and certified for its properties. So you can use in the new construction as well, and that is the whole idea. Because if you want to recycle this aggregate, then you need to put back into new construction. Shiva Kumar has asked this question: how many times used in this demonstrate recycled material? I haven't understood this question very well. How many times have you used in this to demonstrate recycled material? If you are looking at projects, there have been quite a few projects in India where it has been used. We from Sintef has been also working together for a few pilot projects which will start soon. But then there are numerous examples all over the world where it has been used. But generally speaking, in structural concrete, it's not that used as much as you would find in non-structural concrete. What will be the comparison between the both? Cost comparison between both, it again depends on quite a lot of things. It depends if you get a lot of material which is just pure concrete, then you can definitely make your cost of production much lower. The whole problem is that when you produce concrete, you have only 20-30% of your material, or maybe 40% of your material, which can be sold at a higher price. And when I say higher price, we are talking about 500, 600, 700 rupees a metric ton. Most of them goes down in as a brick or loose soil, which will fetch something like 150 rupees a metric ton. And so in on an average, you might get much lower weighted average price. So it is very difficult to give a cost comparison, but then you should also understand that it is not a direct comparison between ecologically sensitive depletion of natural aggregates. You have to put in the right the context. So I think I won't be able to answer much of the questions now. I think the time is up. So thank you very much. And whatever I have not answered, I'll be getting back to you shortly. Thank you so much. Done?